Welcome all of you to the session where we will discuss the subject that is engineering mechanics. The subject is basically for the department who are learning, that is your electrical department and electrical and electronics engineering department. So this is the lecture number 1 and this is the class for introduction. Okay, and the paper code for this subject is ESME 301. First of all, let me introduce myself. I am Subrata Borman, Assistant Professor of Mechanical Engineering Department of Swami Vivekananda Institute of Science and Technology. Okay, let's start. So first we will see the syllabus for this subject, that is your engineering mechanics for electrical department, EE and EEE department. Okay, and this is the syllabus, that is the introduction to vectors and tensor and coordinate system. So here we will basically learn about the vector and tensor and the coordinate system, the vector algebra, tensor algebra. Then how we will learn about the initial notation. Okay, how we will represents the vector in the form of initial notation as well as the tensor. Then we will study about the symmetric and antisymmetric tensor, eigenvalue problem, then the principal axis. Okay, so this is your module number 1. And in the second module we will learn about the three-dimensional rotation, where we will learn the Euler theorem, axis angle formulation, Euler's angles, coordinate transformation of vectors and as well as tensor. Okay, then we will move on the dynamics part of this subject, that is the kinematics of rigid body, kinematics of rigid bodies. Here we will study about the definition and motion of rigid body. Rigid bodies as coordinate system, angular velocity, rigid body and its rate of change, distinction between 2 and 3-dimensional rotation motion, integration of angular velocity, find orientation, then motion relative to rotating rigid body, 5-time acceleration formula. We will derive this formula. This is very important formula for dynamics. We will derive this formula and we will solve some problem regarding about this formula. Then we will study about the kinetics of rigid bodies. Okay, here we will learn about the angular momentum about a point, inertia tensor, which is very important, definition, computation and principal moments. Clear? So we will learn about in detail the inertia tensor. Then we will learn about the moment of inertia of some symmetrical bodies like cylinder, sphere, cone, etc. And area moment of inertia and polar moment of inertia, we will look into that also. Forces and moments. Then we will learn about the Newton-Euler's law of rigid body motion. Okay. Then we will learn we will learn about before going to discuss about all these things, that means the module 1, 2, 3, 4, we will first learn about the free body diagram, what is free body diagram and how the free body diagrams are drawn. You need to understand. Okay, then we will have the general motion, module 6. Then we will study about the bending moment, shear force diagram. We will learn about the different types of loading system, different types of beam and their shear force diagram as well as bending moment diagram. Okay, then we will learn about the torsional motion. Then you have the friction. So basically, first we will study about the free body diagram. Then we will solve some problem. Okay, for this free body diagram. Then we will study about the friction. Okay, then we will move on to the next module as shown. Okay, next. Now these are the books which are the textbooks which we will basically follow, that is the Gel, Merriam and L.G. Craig. The engineering book, the name of this book is Engineering Mechanics. Okay, they are the writer, Merriam and Craig, and this is basically the dynamics. You have also the statics part, static part also for this. Okay, Wiley publications. Then you have the M.A. Beatty, Principle of Engineering Mechanics. Okay, then Manoj K. Harbola. This is the newly published book, Engineering Mechanics. Okay, you can buy this book also. And the reference books I will refer, that is the Vector Mechanics for Engineers, that is F.P. Peer and E.R. Johnstone. Okay, for statics as well as dynamics. Then you have another reference book, you can follow this book also. Okay, next. So first, let me introduce the subjects in engineering mechanics. Okay. Now, the engineering mechanics, so it is the oldest of the physical science. Okay, mechanics is basically the oldest of the physical science. That means it is the branch of physical science that deals with the state of rest or state of motion of bodies or particles subjected to the different types of forces or under the action of forces. Clear? So it is basically the branch of physical science that deals with the state of rest and state of motion. Bodies or particles, and they are subjected to under the different types of loading. Now there are two types of mechanics, basically the rigid body mechanics and the deformable body mechanics. Okay. Under rigid body mechanics, we will study about, we will have two parts, that is your statics and dynamics. First, we will need to understand what is rigid body and what is deformable body. The rigid body, suppose if you have a body like this, the rigid body, that means the body consists of different particles. Okay. If the distance between two particles are negligible, that means if the two particles are very close to each other, then if you apply the load on this body, external load, then we can assume that the deformations of the body because of this loading is negligible. That means the distance between two particles is negligible. Those bodies are called the rigid body. That means although the body has some small deformations, okay, we will consider or we can assume that deformation is very less or negligible. Those bodies are called rigid body. Okay, and the corresponding mechanics is called the rigid body mechanics. Okay, and here we will look into statics and dynamics. What is statics? In static parts, we will see the statics is deals with the state of rest of the body. That means if the body is in rest, okay, under the action of different types of forces, then it is called statics. Okay, and the dynamics means here we will deals with the geometry of the motion. That means here we will deals with the motion of the body, okay, as well as the causes of this motion. That means the forces, motion and acceleration. In dynamics we will we will deal with the motion and acceleration of the body. Clear? Now deformable body are those bodies which will deform under the action of forces. That means if the body is not rigid, then if you apply the load on the body, then the body will deform. Clear? Those bodies are called deformable body, and the mechanics is called the deformable body mechanics, and it is also known as the strength of material. Strength of material. Strength of materials. Okay, and it is also known as the mechanics of materials. Mechanics of materials. Okay, so these are the basically synonyms of this deformable body. Oh, okay, so these are the subject where we deals with the deformable body mechanics. Okay, and you have another, that is your fluid mechanics. That means in the subject fluid mechanics we will learn about the fluid mechanics. Okay, here fluid is considered as the body. Okay, okay, so this is the introduction about the subject engineering mechanics. Okay, and one thing I want to mention, that in dynamics you have two parts, that is one is your kinematics, another is kinetics. Okay, in kinematics we will deal with the velocity and acceleration of the body without considering the forces. Okay, but in kinetics here we will deal with the motion and acceleration along with the forces, okay, acting on the body. Clear? That's all about the introduction to the subject engineering mechanics. In the next lecture we will see we will start with the basic, that is your the free body diagram or the rigid body, equilibrium of rigid body, equilibrium of rigid body. Okay, equilibrium of rigid body. Okay, thank you.